Hi everyone. I want to welcome you to this webinar where we're going to talk about how to optimize your use of Amazon Elastic Block Store, or EBS, to get the best possible storage performance. My name is Jeff Bartley, and I'm a storage specialist on the Solutions Architecture team here at AWS. On the agenda for today, we're going to start off by doing a quick overview of EBS, what it is, how it's different, and some of the common use cases. We'll then review the different EBS volume types and how to select the right volume type for your workload. From there, we'll talk about EBS-optimized EC2 instances, how they work, and the importance of selecting the right instance type to match your EBS volume configuration. We'll also look at burst performance on EBS volumes and how this can be used to optimize both cost and performance for certain workloads. We'll then look at elastic volumes, an EBS feature that allows you to dynamically modify volumes. Finally, we'll wrap up with a few additional optimizations, both around performance and cost, that you'll want to consider when using EBS. So let's start with a quick overview of EBS. EBS was built with the customer in mind. EBS delivers on all functional levels: speed, cost, elasticity, availability, security, and scalability. For example, SSD-backed IO1 volumes deliver up to 64,000 IOPS and 1,000 megabytes per second of throughput per volume. You can use multiple volumes for even greater performance, up to 80,000 IOPS or 1,750 megabytes per second of throughput per instance. For simplicity, our elastic volumes feature allows you to move between different volume types or scale up storage capacity with no disruption to your workload. These are just a couple of examples of the functional advantages EBS provides. We have scaled and architected EBS to offer industry-leading performance and functionality for the vast list of entities that AWS customers represent, from first-time builders to global enterprises to major government institutions. Amazon EBS is block storage as a service. With an API call, you configure block storage volumes and attach those volumes to EC2 instances. Volumes can be up to 16 terabytes in size, and EBS provides several volume types to meet the performance needs of your applications. EBS is a service that is accessed over the network, providing you with a number of benefits that we'll discuss in the next few slides. When an EBS volume is attached to an instance, it will look like a disk. But it's important to remember that an EBS volume is not a single physical drive. Instead, EBS is a distributed system, and each EBS volume is made up of multiple physical devices. By distributing a volume across many devices, EBS provides added performance and durability that you can't get from a single disk device. An important characteristic of EBS volumes is that they can live independent of EC2 instances. This gives you the ability to select and change storage and compute based upon your workload, selecting just the right resources to meet your application needs. This means that you can detach a volume from one instance and reattach it to a different instance within the same availability zone. The data on the EBS volume is completely preserved and made instantly available to the new instance. A single EC2 instance can have multiple volumes attached to it. However, an EBS volume can only be attached to one instance at a time. As a best practice, it's recommended to separate boot volumes from data volumes. You want to keep boot volumes as small as possible and store your data on separate volumes. This gives you the flexibility to adapt the storage architecture to your needs. These are some of the workloads our customers are using EBS for. SSD-backed volumes provide low latency storage that's ideal for random access patterns, such as those found in relational and NoSQL databases. Workloads that access data in large sequential patterns, such as data warehousing, Hadoop, and streaming media workflows, work well on HDD-backed volumes. So let's talk about the different EBS volume types. EBS volumes fall into two categories. SSD-backed volumes are optimized for transactional workloads involving frequent read-write operations with small I/O sizes, where the dominant performance attribute is input-output operations per second, or IOPS. HDD-backed volumes, on the other hand, are optimized for large streaming workloads where throughput, which is typically measured in megabytes per second, is a better performance measure than IOPS. Under the SSD-backed volume category, we have two types of volumes. GP2 volumes offer cost-effective storage that's ideal for a broad range of workloads. IO1 volumes are designed to meet the needs of IO-intensive workloads, particularly database workloads that are sensitive to storage performance consistency. Under the HDD-backed volume category, we also have two types of volumes. ST1 volumes are optimized for throughput and are a good fit for large sequential workloads such as log processing and streaming media. SC1 volumes provide inexpensive storage for infrequently accessed sequential workloads. So, how do you choose the right storage for your workload? Well, most I/O workloads are either IOPS driven, where data is accessed in small chunks, often randomly, or throughput driven, where data is read or written in large sequential chunks. Knowing the I/O patterns of your workload is the key to choosing the correct EBS volume type. If your workload is IOPS driven, then the first thing you want to consider is how many total IOPS your application will need. Today, an EBS-optimized EC2 instance can provide up to 80,000 IOPS to EBS, depending upon the instance type. If your application requires more than 80,000 IOPS, then you'll want to use an EC2 instance type that provides local NVMe instance storage, such as i3, C5D, M5D, R5D, and other EC2 instance types. Keep in mind that instance storage, unlike EBS, does not persist beyond the life of the instance. Applications that use instance storage should use replication or other methods to provide additional levels of durability if required. The next thing to consider is latency, which is the time it takes for an I/O request to be acknowledged by the storage. EBS SSD-backed volumes provide low single-digit millisecond latencies. If your application requires sub-millisecond latency, then again, you'll want to use instant storage. Otherwise, your next consideration is cost versus performance. If cost is more important, then you'll want to use GP2 volumes. GP2 volumes satisfy nearly all workloads and are designed to be truly general-purpose volumes. GP2 volumes provide baseline performance of 3 IOPS per gigabyte, up to 16,000 IOPS. Volumes smaller than 1 terabyte can burst to 3,000 IOPS for a period of time, depending upon the size of the volume. GP2 volumes provide up to 250 megabytes per second of throughput and deliver single-digit millisecond latency. A single GP2 volume can be allocated up to 16 terabytes in size. Because of its bursting capabilities, GP2 volumes are ideal for boot volumes, as well as bursty, IOPS-driven workloads. So GP2 volumes are a good choice if your workload is IOPS-driven and cost is the most important factor to you. But if performance consistency is more important, then you'll want to choose IO1 volumes. IO1 volumes provide up to 4 times the performance of GP2 volumes, delivering up to 64,000 IOPS and 1,000 megabytes per second on Nitro-based instances. On all other instance types, IO1 volumes can deliver up to 32,000 IOPS and 500 megabytes per second. One of the advantages of IO1 volumes is that IOPS can be provisioned independently from capacity, up to 50 IOPS per gigabyte. This allows you to use smaller volumes while still reaching high levels of performance. IO1 volumes are designed to provide high performance consistency and better latency consistency than GP2 volumes, making them ideal for mission-critical workloads that require sustained performance over time. Now, what if your workload is more throughput-driven than IOPS-driven? Again, if your workload is small, random I/O, then you'll want to choose an SSD-backed volume. But if your workload generates large sequential I/O, then the next question to consider is how much total throughput your application requires. We mentioned earlier that EBS-optimized EC2 instances have an upper limit of 80,000 IOPS today. A similar upper limit exists for throughput. Today, EBS-optimized EC2 instances can provide up to 1,750 megabytes per second of throughput to EBS. If your application requires higher throughput than this, then you'll want to use H1 or D2 EC2 instances that provide local HDD-based instance storage. Otherwise, it again comes down to cost versus performance. If throughput performance is more important than cost, then you'll want to choose ST1 volumes. ST1 is our throughput provisioned volume type, designed for active, large sequential workloads. However, instead of measuring performance in IOPS, we measure performance in megabytes per second. Like GP2 volumes, ST1 volumes have both baseline and burst performance levels. ST1 volumes provide baseline performance of 40 megabytes per second per terabyte, up to 500 megabytes per second, and they can burst at 250 megabytes per second per terabyte, up to 500 megabytes per second. When planning storage capacity for either ST1 or SE1 volumes, remember that the minimum volume size is 500 gigabytes. So you'll want to choose ST1 when your workload is throughput-driven and performance outweighs costs. However, if cost is more important than performance, then you'll want to choose the SC1 volume type. SC1 is another throughput provisioned volume type that's designed for workloads with more modest performance needs. SC1 volumes provide baseline performance of 12 megabytes per second per terabyte up to 192 megabytes per second, and they can burst at 80 megabytes per second per terabyte up to 250 megabytes per second. But what if you're not sure what your workload looks like? If you don't know the I/O profile of your workload, we recommend that you start with GP2 volumes at the lowest capacity needed. Using the EBS elastic volume feature, you can always change the volume type and increase capacity as needed. Now, let's take a look at a few examples of how customers use EBS volumes in real-world scenarios. Enterprise customers run SAP HANA on AWS and use EBS volumes to meet the required performance KPIs. Mission-critical SAP HANA applications will often run on the X1 family of EC2 instances. This instance type can scale up to 4 terabytes of RAM and provide up to 1,750 megabytes per second of EBS throughput. SAP HANA services have different I/O needs and can take advantage of the different types of EBS volumes. For example, the SAP HANA log requires consistent low latency storage, so it makes sense to use IO1 volumes here. HANA backups, on the other hand, write data in large sequential chunks, making it an ideal workload for ST1 volumes. By mixing and matching the right EBS volumes for the right service workloads, customers can optimize their SAP HANA deployments for both cost and performance. Infor is an AWS customer that provides business applications with last-mile functionality and scientific insights. Some of these applications are built on Microsoft SQL Server. To address the needs of many of their mission-critical customers, Infor will deploy applications on I2 instances clustered across multiple availability zones. To maintain strong performance for transactional workloads, they use I2 instance storage for data volumes and ST1 for their transaction logs. Infor's original architecture used GP2 volumes for both full and partial backups. However, they found they could achieve higher throughput by moving to ST1 volumes. This reduced their backup window by 30% and also led to significant cost savings. While selecting the right EBS volume type is important for optimal performance, choosing the correct EC2 instance to attach your EBS volumes to is equally important. In this next section, we'll talk about EBS-optimized EC2 instances, the benefits they provide, and how to select the right instance for your workload. EBS-optimized EC2 instances use an optimized configuration stack and provide additional network bandwidth that's dedicated solely to EBS. With dedicated bandwidth, EBS activity doesn't compete with other network activity on the instance, leading to more consistent I/O performance. Most current generation EC2 instances are EBS optimized by default. On these instances, there's no need to enable EBS optimization, and there's no effect if it's disabled. On some older EC2 instance types, EBS optimization can be enabled either at instance launch or while the instance is running. To get the best EBS performance, you'll want to use EBS optimized instances. Check out the link shown here for a complete listing of EBS optimized EC2 instances and their performance capabilities. Each EBS optimized EC2 instance type provides a specific amount of baseline bandwidth to EBS. Choosing the right instance type means choosing an instance that will provide the level of IOPS and throughput required by all EBS volumes attached to your instance. For example, a C4 large instance type has a baseline of 4,000 IOPS dedicated to EBS. This provides 500 megabits per second of throughput, or about 62.5 megabytes per second when using 128 kilobyte I/O sizes. But if you attach a 2 terabyte GP2 volume, which is capable of up to 6,000 IOPS and 250 megabytes per second of throughput, then the instance can't provide the maximum bandwidth that the volume is capable of. So, you'll want to make sure you choose an instance type that provides the bandwidth needed by the EBS volumes. In this particular case, a C4 4x large instance will give you the bandwidth needed to deliver on both IOPS and throughput. In addition to having a baseline level of dedicated EBS bandwidth, some EC2 instance types can also burst to higher levels of performance. For example, C5 large instances have baseline performance of 64 megabytes per second and 4,000 IOPS. However, they can burst up to 437 megabytes per second and 20,000 IOPS for 30 minutes at least once every 24 hours. These instance types are a good choice for workloads that need much higher performance than normal, but only for short periods of time each day. While some EBS customers have workloads that require sustained performance over long periods of time, many workloads are bursty, with a low baseline performance requirement marked by occasional spikes of activity. Understanding how the burst model works with some EBS volume types can help you maximize both performance and cost savings. All EBS volumes that support bursting operate on a token bucket model. For GP2, your volume is always accumulating credits at a rate of 3 IOPS per gigabyte of volume size, with a minimum of 100 IOPS. For example, a 100 gigabyte volume accumulates 300 credits every second. The bucket that is collecting the credits is fixed in size at 5.4 million credits. A volume can't accumulate more credits than this. With GP2 volumes, you can spend credits at the rate of 3,000 IOPS or 3 IOPS per gigabyte, whichever is higher. So, a 1 terabyte volume will accumulate credits at the same rate that they can be spent, which means that you will never run out of credits with a volume of that size. Volumes that are smaller than 1 terabyte accumulate credits at a slower rate than they can be spent. So, if you're running at 3,000 IOPS over a sustained period of time, you will eventually deplete the credits in the bucket and your performance will drop to the baseline performance of the volume. This graph shows how baseline performance increases with the size of the GP2 volume. The minimum volume size to achieve maximum IOPS is 5,334 gigabytes. We got to that number by dividing the maximum IOPS, which today is 16,000, by the 3 IOPS per gigabyte ratio that GP2 volumes provide. Volumes less than 1 terabyte in size can burst to 3,000 IOPS, and small volumes have a 100 IOPS minimum baseline. For example, a 300 gigabyte volume has a baseline of 900 IOPS but can burst to 3,000 IOPS for a period of time. But how long is that time? With a refill rate of 3 IOPS per gigabyte, the amount of time you can burst is dependent upon the volume size. The bigger the volume size, the longer you can burst. The smallest GP2 volumes can burst at 3,000 IOPS for 30 minutes, or enough for a few reboots. As the volume grows, the amount of burst time grows. A 300 gigabyte GP2 volume can burst for 43 minutes. A 500 gigabyte volume can burst for 1 hour, and a 950 gigabyte volume can burst for 10 hours. Throughput volumes have the same token bucket model as GP2, except performance is measured on a different vector. Volume size determines the baseline throughput of your volume and is the rate at which the volume accumulates throughput credits. For example, a 2 terabyte ST1 volume will accumulate credits at a rate of 80 megabytes per second. Volume size also determines the burst throughput of your volume, which is the rate at which you can spend credits when they are available. ST1 volumes can burst at 250 megabytes per second per terabyte with a max burst throughput of 500 megabytes per second. SC1 volumes can burst at 80 megabytes per second per terabyte with a max throughput of 250 megabytes per second. Larger volumes have higher baseline and burst throughput. The more credits your volume has, the longer it can drive I/O at the burst level. Unlike GP2 volumes, which have a fixed credit bucket size, throughput volumes have a bucket size proportional to the size of the volume. The larger your volume, the more burst credits you can accumulate. Here's a quick look at the burst and baseline throughput model for the ST1 volume type. Since ST1 volumes burst at a rate of 250 megabytes per second per terabyte, at a 2 terabyte volume size, you're already bursting at the maximum rate. As the volume size grows, the burst rate doesn't increase. You just accumulate credits at a faster rate, thus increasing the time you can burst for. Baseline performance grows with the volume size until baseline reaches burst, which happens near 12.5 terabytes. Here's a quick example of an 8 terabyte volume, which can get 320 megabytes per second of baseline throughput and can burst to 500 megabytes per second. And here's the model for the SC1 volume type, which has similar characteristics to ST1. The throughput characteristics and burst are still very good, better than you would get from commodity spinning disk drives. Notice, however, that even at the maximum capacity, the baseline performance never reaches the burst performance. EBS provides CloudWatch metrics that allow you to monitor your burst balance. In this graph, you can see the burst balance in blue and write operations to the volume in orange. A sustained I/O load over a period of 1 hour eventually depletes the burst balance. Once the I/O load is stopped, the credits begin to accumulate over time until the balance returns to 100%. If you're using GP2, ST1, or SC1 volumes and find that your burst balance is often being fully depleted, you can use the elastic volumes feature of EBS to increase your volume capacity and thus increase the amount of time that you can burst. So what is the elastic volumes feature? Well, sometimes it can be difficult to know ahead of time what the exact needs of a particular workflow might be. Amazon EBS removes a lot of the guesswork around storage planning with its elastic volumes feature. When using EBS, it's always best to start with the minimum amount of capacity to reach the needed performance. Then, using the elastic volumes feature, you can increase volume size, change from one volume type to another, or increase or decrease provisioned IOPS on IO1 volumes. There's no cost to modify volumes, and the changes are made dynamically with no downtime required. Modifying a volume is straightforward. Although it's not required, we recommend taking a snapshot of the volume before you modify it. Then, you can modify the volume using the AWS Management Console or the AWS CLI or API. Depending upon the type of modification, it could take a while for the change to be fully completed. Once the modification is finished, you can extend the file system if the change involved increasing capacity. Let's walk through these steps in more detail. To take a snapshot of the volume, you can either use the CLI or API as shown on the left, or you can use the AWS Management Console by selecting your volume, clicking on the Actions button, and selecting Create Snapshot. Once you have a snapshot of your volume, you can then proceed to modify the volume. In this example, we are going to modify our GP2 volume by changing it to an IO1 volume, significantly increasing the IOPS and increasing the capacity from 1 terabyte to 5 terabytes. These changes can all be made at the same time, as shown in the CLI command on the left. You can monitor the modification status of the volume by using the Describe Volumes Modifications command in the AWS CLI. You can also monitor the state of the modification from the AWS Management Console. When a volume modification is started, it will begin at the modifying state. After a period of time, the volume will transition to the optimizing state. Again, depending upon the requested modifications, this step can take some time. Once the volume has been fully optimized for the new volume configuration, the modification is complete. If the volume size was increased and you are using an ext or XFS file system on Linux, you can grow the file system using the command shown here. These steps are also documented in the EBS product documentation. You can do the same thing on Windows using the disk management utility. Select your volume and then right-click the volume or click on the action menu. Select Extend Volume from the menu and then enter the new capacity of the volume up to the total volume size available. You can also use PowerShell commands to automate this, as noted in the link below. A few tips when using elastic volumes. First, when changing volume types, remember to keep volume specifications in mind. For example, while the minimum volume size for a GP2 volume is 1 gigabytes, the minimum size for an IO volume is 4 gigabytes, and the minimum size for an ST1 or SC1 volume is 500 gigabytes. If you try to change a volume to a different type, and the volume specifications for the new volume type are not met, then the modification will fail. Second, modifications are currently limited to once every 6 hours. Third, unlike older instance types, current generation instances do not need to be stopped and restarted, nor is a volume reattach required to see the effects of the modification. However, this is required on any volumes that were created before November 1st, 2016. The AWS ecosystem provides a wide array of tools for building automated solutions. Let's talk about how you can use Elastic Volumes, Amazon CloudWatch, and AWS Lambda to do some cool things. Specifically, thinking about right-sizing, you can publish a metric to CloudWatch to track how much free space is left on your file system. When you approach an upper limit, you can use a Lambda script along with EC2 Systems Manager to increase the volume size and extend the file system to use a new capacity. You can use a CloudWatch alarm to monitor volume performance or burst balance and modify the volume accordingly. You can also initiate a workload to provision additional IOPS during times when higher performance is needed, say during a nightly database backup. Check out this GitHub site for automation ideas around elastic volumes. Now, there are a few other things to consider when optimizing EBS. Sometimes a single EBS volume alone won't provide the capacity or performance required by your workload. In that case, you'll need to combine multiple EBS volumes together to form a single logical volume. This is typically referred to as striping or RAID 0. You can use a RAID 0 configuration to provide more than 16 terabytes of EBS storage to your application. You can also use striping to achieve throughput or IOPS beyond what a single volume can provide. And for bursty workloads, you can stripe multiple GP2 volumes together for low-cost, high IOPS storage. When using RAID 0, remember to size your EC2 instance accordingly to get the proper EBS bandwidth. Also, remember to use similar volumes in your stripe set. Mixing different volume types or different capacities will result in uneven performance. You'll want to avoid using RAID for redundancy, such as in RAID 1, RAID 10, or RAID 5 or RAID 6 configurations. There are a few reasons for this. First, remember that EBS is replicated across multiple physical devices, so it already provides protection against component failure. Second, when you mirror data, such as with RAID 1, you cut your available EBS bandwidth in half or more, since each I/O has to be written to multiple volumes. It's the same with RAID 5 or RAID 6. The I/O required for parity reduces overall EBS bandwidth. Well, we've talked a lot today about optimizing EBS performance. Before we wrap up, I just want to mention a few ways to optimize your EBS costs as well. First, remember that you pay for EBS volumes whether or not they are attached to an EC2 instance. Volumes that are not being used can be deleted to avoid ongoing charges. If you need to retain the data on the volume, you can always create a snapshot before deleting, using tags on the snapshot as metadata for cataloging. Second, you can save costs by deleting old snapshots. Now, it's important to keep in mind that because EBS snapshots are incremental, deleting a snapshot may not always yield the expected cost savings, since blocks that have been unchanged need to be retained for newer snapshots. Generally, we recommend that customers use services like Amazon Data Lifecycle Manager or AWS Backup to set retention policies so that older snapshots are automatically deleted after a certain amount of time. Third, you can reduce costs by changing the volume type. For example, you might have an ST1 volume that's no longer accessed as frequently as it used to be. By changing to an SC1 volume, you could reduce your monthly charges significantly. EBS Elastic Volumes makes it easy to change the type of volume. Fourth, you can reduce your costs by using EBS native encryption rather than rolling your own. EBS volumes and snapshots can be encrypted at no additional cost using an AWS managed key. For customers that want greater control over their encryption keys, volumes and snapshots can also be encrypted using KMS keys. So in summary, when optimizing EBS for higher performance, consider the following. First, make sure to select the right EBS volume type for your workload. If you need high IOPS or low latency, use GP2 or IO1 volumes. If you need high throughput, use ST1 or SC1 volumes. Second, select the right instance for your workload. Wherever possible, use EBS-optimized instances and make sure that the EBS bandwidth provided by the instance is sufficient for the aggregate bandwidth required by all volumes attached to the instance. Finally, always start small. The elastic volumes feature of EBS allows you to easily increase capacity, change volume types, and adjust provision IOPS as needed. And that's it. Thank you very much for your time.